Alright guys, today we're going to talk about logistic functions. And what logistic functions are is essentially the way an exponential function truly operates like in the real world. Okay, when things grow exponentially, they tend to level off. There tends to be some kind of limitation, some type of maximum that it can't really get above. That's how it tends to be. Now I'm not saying that a true exponential function can't really exist where it's an infinite increase. But for the most part, this is what we're looking at. We're looking at the initial stage of growth, the exponential stage of growth, and then it starts to dampen. It starts to flatten out and then become an equilibrium right around where it says here there's the limitation. Now the limitation is the maximum sustainable amount of things that we're dealing with in whichever scenario we're talking about. The maximum sustainable population. Okay? So we'll have a problem very similar to the problem we have here. I'm going to paraphrase. Suppose we have a 400 square mile ranch that's dedicated to repopulating the earth with the black bear. A little research tells us that the black bear thrives when there's only 1.5 black bears per square mile, and that they reproduce, they grow at a rate of 35%. So we need to somehow write a difference equation that demonstrates the growth with the limitation based on the land area that we have available. So here I have the difference equation. This says that the difference in the population over time is going to be the rate as a decimal divided by whatever the limitation is times the current population times the limitation minus that current population. Okay? So that's going to be the difference from one year to the next. To be the difference. So if you subtracted the populations, that's what this answer would give you. I'll show you how that works here in just a second. So first we have to find this infamous limitation. What is this limitation we're talking about? Where we have a 400 square miles. And we don't know how many black bears can fit inside that 400 square mile. But we do know that for every 1 square mile, 1.5 black bears live comfortably, thrive. So if we do here a little cross multiplication, a little proportion work, we'll see that our limitation, this limitation for our black bear population, this X, is equal to 600 black bears. So I know that my population, my maximum sustainable population, 600 black bears. I also know here that my growth rate is 35%. 35% as a decimal is 0.35. So I can write my difference equation real fast. My difference equation here is 0.35 divided by 600 times A times 600 minus A. That is my difference equation for this growth rate of black bears if we are limited to a 400 square mile ranch. Okay? So, if we start with 10 bears, we're going to start with 10 bears. How much would we have the first year, after the first year of this ranch, after first year of this rededication, repopulation project? Okay, well, it's real simple. We're going to take this 10 bears and we're going to plug it in here for A. Now this is going to be probably where we use our calculator a little bit, but we have 0.35 divided by 600 times 10 times 600 minus 10. That's going to give us somewhere in the ballpark of 35% of 10. Okay? However, whatever we get here, we're going to have to add 10 back to it. We're going to have to add 10 back to it. So I'm going to go ahead and take out my cell phone device, and I'm going to calculate what this is. It's very simple. I'm going to just do each one of these in order. I'm going to actually go ahead and subtract this first because it's in parentheses, and that is what order of operations tells us to do. So 600 minus 10 is 590. In case you don't know, it's 590. Okay, then we're going to multiply by 10, and then we're going to multiply by 0.35, and then divide by 600. Okay, and then I got 3.4. 3.4. That's real close to 3.5, which would be 35%. It's real close, but we are limited, so that it's not exactly 3.5. And then it says we have approximately 13.4 black bears after the first year of this project, after this rededication project. Now, if I want to know how many we're going to have after that second year, well, we had 10 the first when we started at year 0. That's year 0. Then we have 13.4 year 1. Well, so I need to know what about year 2. So year 2, I'm going to take this 13.4 and plug it in here for this, where this 10 is. So we got 0.35 divided by 600 times 13.4 times 600 minus 13.4. That's going to equal something plus 13.4. Notice how every time there was a 10 in the first time, I then put 13.4 in the second time. And again, I'm going to do this real quick. 600 minus 13.4, that's 586.6. 586.6 times 13.4 times 0.35 divided by 600. That's 4.585. So that's 4.6 approximately. 4.6. And if we add 4.6 to our 13.4, we have 18 black bears approximately in year 2. And this is how you do the logistic function. And this is actually a recursive pattern that we're doing year after year. We're doing the same thing year after year, so it's kind of a pattern. But this tells us our logistic growth.